Welcome to the section 11.1, 11.3 review. This is just on surface area of prisms, cylinders, pyramids, and cones, and then some composite solids. The review should be pretty similar to the test. So let's take a look at the questions on the review. Okay, the first one says find a regular decagon with side lengths of 10 and a height of 15. There were some questions about that today, so let's try and come up with a picture of what that would look like. Let's make it a little bigger. So if it has 10 sides, there it is, and let's oops, I'm going to bring that down. Okay, so if it's this prism, let's see if I can get this to work. Let's see. So it actually looks, I just want you to get the general idea of what this looks like. Okay, so that's kind of what that looks like. And I think there were some questions today when it said side length, what did that mean, and height. And I think sometimes you think of height is it has to be vertical, but in this case it's not. The height of the prism is the part that is perpendicular to those parallel bases. So the height is actually this length right here. The side length is the length of one of these sides of this hexagonal or decagonal hedron. So it has 10 sides. So now let's take a look at what that actually means in terms of finding this. I'm going to get rid of some of this. I have a lot on this. Delete that. Okay, so one of the sides has a length of 10, and then the height of this is 15. We'll get to that in a minute. So if I'm looking at this, I have to find the area of the base. The lateral area, remember, is the perimeter times the height. The surface area is equal to the lateral area plus 2 times the area of a base. So let's take a look at this base. That means I have 10 sides, so 360 divided by 10 gives me a central angle measure of 36 degrees. And when I construct that apothem, I'll draw that triangle over here, I bisect that central angle, and this angle measure becomes 18 degrees. It also bisects the side of this triangle, the base, so that means that this would be 5, and I need the apothem. In case you've forgotten, the area for a regular polygon is 1/2 the apothem times the perimeter. So I need the length of the apothem. I'm going to use tangent of 18 is equal to 5 over a, so a is equal to 5 divided by tangent of 18, and so a would be 15.40. So that's my apothem. So now the area of my base is 1/2 the apothem, 15.4, times the perimeter. Well, the perimeter, the number of sides is 10. The length of each side is 10. So now the area of my base is 770. And I'm going to need that piece of information when I'm finding the surface area. So now let's go over to the lateral area. Lateral area is the perimeter. Remember, we said the perimeter is the number of sides times the side length. Number of sides times the length of a side. So I have 10 sides, each side is 10, so therefore my lateral area is equal to 100 times the height, which is 15. Okay, so that gives me a lateral area of 1500. Then my total surface area is the lateral area, 1500, plus 2 times the area of a base, and the base was 770. So my total surface area for this would be 3040. Okay, so what you need to do is you need to think about what pieces make up this prism. Okay, what pieces make up this prism, and then come up with all of those sides. Next one is a regular pentagonal hedron with side lengths of 16 and a height of 12. So again, let's take a look at what that looks like. And oh, I don't need that one. Okay, let's copy this one. Okay, so if this is a pentagonal hedron, let's again draw these lines so you get an idea. Remember, the bases are parallel and congruent. So this is a base, and this is a base. The height is the perpendicular length, so that means that this is 12. The length of a side is 16. So if this is my pentagonal hedron, let's put another one here, I'm going to be looking at this shape in particular as my base. Okay, let's go back again. Remember that the lateral area is equal to the perimeter times the height. The surface area is equal to the lateral area plus 2 times the area of a base. So let's first take a look at lateral area. If I'm looking at this shape, the perimeter of this pentagon is 5 times 16. Which is 80. Okay, so now I have my lateral area is the perimeter, 80 times my height, which is 12. That gives me a lateral area of 960 units squared. Now my surface area, I need to find the area of the base. That's why I drew this one down here. So again, I'm going to construct that central angle. Remember, that's 360 divided by the number of sides. In this case, it's 5. Gives me a central angle measure of 72. When I construct that apothem, I bisect that angle, making that 36 degrees, bisect the side, making that 8, and I need to find the apothem. So tangent of 36 is equal to 8 over a. Variables down low, they trade places. So a is equal to 8 over tangent of 36. So 8 divided by tangent of 36 is 11. So a is approximately equal to 11. So now, again, I'm still looking for the area of that base. So I have to go to the formula. Area is equal to 1/2 the apothem times the perimeter. So 1/2 11 times 80. 1/2 11 times 80 is going to give me 440. So I'll substitute that value in for B. So my surface area is equal to 960 plus 2 times 440. Gives me a total surface area of 1,840 units squared. Okay, so don't be confused by the words. Remember, the height, whether it's oriented vertically or horizontally, is the perpendicular height. It's perpendicular to the base. Okay, let's take a look at number 3. Now I have a right circular cylinder with a radius of 3 and a height of 8. Again, the lateral area. This time, instead of saying perimeter, we're going to say circumference. Remember, the circumference of a circle is 2 pi r times the height, which is h. So the lateral area is 2 pi times the radius times the height. So that's going to be 48 pi for the lateral area. Then, remember, the surface area is equal to the lateral area, which is 48 pi, plus 2 times the area of a base. This time the base is a circle, so I'm going to use pi r squared. So 48 pi plus 2 times pi times the radius squared. The radius is 3. When I square that, I get 9. So I have 48 pi plus 18 pi. That's going to give me 66 pi centimeters squared as the area of surface area of this circular cylinder. The next is a rectangular prism. Again, the lateral area is equal to the perimeter times the height. Total surface area is equal to the perimeter, or the lateral area plus 2 times the area of a base. So the perimeter, remember, we're looking at the perimeter of a base. The perimeter of the base is here. So that's 3 plus 4 plus 3 plus 4. So the perimeter of this shape is 14. Sorry, it's 14. Tired today. The perimeter is equal to 14, so my lateral area is equal to the perimeter 14 times the height, which is 6. So that's 14 times 6, which is 84. 84 inches squared. Then the total surface area is equal to the lateral area, 84 plus 2 times the area of the base. Well, the base is 4 times 3, which is 12. So I have 84 plus 2 times 12, which is 24. So I have 108 inches squared for the area of that surface area of that rectangular prism. Next, I have a hexagonal pyramid. Okay, remember the formula changes here a little bit. For the hexagonal prism, the lateral area is equal to 1/2 the perimeter times the slant height. This one's a little tricky because you're given that 10 centimeters, but that's not really the slant height. That's an edge length. If we're looking at this, let's see, let's pick that. If we're looking at this particular triangle, I guess it doesn't like that color. This particular triangle right here, that's actually an edge length of 10. This is 6.5. What we need to find is this slant height that is perpendicular to the base. So that means I'm going to put in that height, bisect this, so it's 3.25, and I need to find this slant height right here. So I have 3.25 squared plus L squared equals 10 squared. So that's 10.56 plus L squared equals 100. So L squared is equal to 100 minus 10.56, 89.4. And so that slant height L is equal to 9.5. So now my lateral area is equal to 1/2 the perimeter. Perimeter is 6.5 centimeters times 6 sides times the slant height, which is 9.5. Which gives me a lateral area of 185.25. And now when I look at this base, the base is a hexagon. And I have to find the area of the base, because to find the surface area, I'm going to take the lateral area plus 1 base. I will construct my central angle. Now this is a regular hexagon, so you can use special right triangles or you can use the trig ratios. You don't have to keep it in simplest radical form. If you choose special right triangles, you can change that. Okay, so I know that this is an equilateral triangle, meaning each of these central angles is 60 degrees. When I bisect that angle, I get 30 degrees. It bisects the side, which gives me 3.25, and I need the apothem. So if I use tangent of 30 is equal to 3.25 over A. Again, they're going to trade places, so 3.25 over tangent of 30. Okay, gives me an apothem of 5.63. So now I have the apothem. I'm going to use the area is equal to 1/2 the apothem times the perimeter. Sorry about that, had to hook up some power. Okay, so I want to find the area of the base. Area of the base is equal to 1/2 the apothem, 5.63, times the perimeter, which is 6.5 times 6, 39. So remember, this is the area of a base. 0.5 times 5.63 times 39 gives me 109.8. So now my surface area is 185.25 plus 1 base, 109.8. Surface area is 295.05. Okay, next one, little easier. The next one's a little easier because now, do you see that dotted line? That's down the center of that triangle. So that is the slant height. So that makes this one a little easier to look at. I'm looking for the lateral area, which is the 1/2 the perimeter times the slant height. 1/2 the perimeter. Well, the perimeter is just going to be 4 sides times 6 centimeters each, 24 centimeters. So 24 times the slant height, which is 9. It's going to give me a lateral area of 108 centimeters. Now I have to find the area of the base, because the total surface area is the lateral area plus the area of a base. So the area of the base is 6 times 6, because it's the side squared, which is 36 meters. So my total surface area is 108 centimeters plus 36 centimeters, which is 144, not centimeters, sorry, that's meters. I made that centimeters. On yours, it's meters. We'll just go with yours, meters squared. Okay, number 7, remember we talked about this one in class. To find the surface area of this solid, you have to first find the lateral area of the outside cylinder, plus the lateral area of the inside cylinder. Okay? Then when you want the total surface area, actually let's come back to that. Let's just go ahead and find those two. So my lateral area is the lateral area of the outside cylinder. If that is 3 inches in diameter, then it has a radius for the large circle of 1.5. So remember now it's the circumference 2 pi r times the height for this lateral area of a cylinder. So in this case, the lateral area of the outside cylinder is 2 pi times 1.5 times 6. I'm going to add to that then the lateral area of the inside cylinder. And if that's 1 centimeter, the radius is going to be just 0.5. So I have 2 pi times 0.5 times the height, which is 6. So I'm going to have 2 times 1.5 times 6, 18 pi, plus 0.5 times 2 times 6, 6 pi. So my lateral area for this solid is 24 pi. Now remember, my total surface area is the lateral area plus 2 times the area of a base. So the area of a base in this case is the area of the large circle minus the area of the small circle. So in this case, that's pi times the radius 1.5 squared minus pi times the radius 0.5 squared. So that's going to give me 1 base is 2 pi. So the total surface area is the lateral area, 24 pi, plus 2 times the area of a base, 2 pi, which gives me a total surface area of 28 pi. Okay. Number 8, okay, now remember, this is a solid. You have a cylinder with a cone on top. You can't touch that region between the cylinder and the cone. It's one solid piece. So when you look at this piece to find the lateral area for this solid would be the lateral area of the cylinder plus the lateral area of the cone. Okay, so the lateral area, remember, is going to be 2, their circumference times the height, so 2 pi r h. Then the lateral area of the cone is going to be 1/2 2 pi r h, not h, sorry, that's L. Remember, this one's the slant height. So here, 2 pi r L. Well, when I look at this, I have a right triangle here. I know the height is 4. The radius of this circle is 3. So I can use the Pythagorean theorem to find L. So I have 3 squared plus 4 squared equals L squared. 9 plus 16 equals L squared. Square root of 25 equals L. So L is equal to 5. The slant height is equal to 5. So now let's find the lateral area of this solid. So for the cylinder, 2 pi times the radius 3 times the height 8 plus 1/2 2 pi times the radius, which is 3, times the slant height, which is 5. That gives me 48 pi for the lateral area of the cylinder, plus 15 pi for the lateral area of the cone. Then I need to just add those together. 48 plus 15, I get a total lateral area of 63 pi. The total surface area, remember, is the lateral area plus only one base this time. We only have one base. The area of the base, it's a circle, so pi r squared. The radius is 3. So 3 squared is going to give me a base of 9 pi. My lateral area was 63 pi plus one base, which is 9 pi, gives me 72 pi as the area, the total surface area of this solid. Number 9, again, we have a rectangular prism or a square prism with a square pyramid on top. My lateral area is equal to my perimeter times my height for the prism. My pyramid, the lateral area of my pyramid, is equal to 1/2 the perimeter times the slant height. Again, I don't have that slant height, so I'll have to use the Pythagorean theorem for that. So let's first find the lateral area of the prism, which is this base. That's the perimeter, 3 times 4, there are 4 sides, which gives me a perimeter of 12 times the height, which is 6. So 12 times 6 is 72. Now I will need the lateral area of the pyramid, so that's 1/2 the perimeter, which is 12 times the slant height, and that part I don't have. If the length of a side is 3, this is half of it, so this is 1.5. So I'll use the Pythagorean theorem. 1.5 squared plus 3 squared equals the slant height L squared. This is 2.25 plus 9 equals L squared. So the square root of 11.25, which is a slant height of about 3.4. So that's about 3.4. So my lateral area of the pyramid is about 20.4. So when I'm looking for the total surface area, I need the lateral area of the prism plus the lateral area of the pyramid plus one base. So it looks like all I have to find now is just the base. I have the lateral area of the prism, which is 72, the lateral area of the pyramid, which is 20.4, and the area of a base, which is 9. So 72 plus 20.4 plus 9 gives me total surface area of 101.4 units squared for number 9. Okay. Next one. Okay, remember this one. This is, you have a cylinder and you have a cone on the inside. So this lateral area is the lateral area of the cylinder plus the lateral area of the cone. Okay, the diameter is 10. That means the radius is 5. Lateral area, remember, is the circumference, 2 pi r times the height for the cylinder. The lateral area of the cone is going to be 1/2 the circumference, 2 pi r times the slant height. So I don't have the slant height. I'm going to have to find that slant height using the Pythagorean theorem. So L is equal to 5 squared plus 12 squared, or L squared. So that's 25 plus 144. That's equal to 169. So L is equal to 13. I'm going to take the square root of both of those. So my lateral area of my cylinder is 2 pi times my radius, 5, times my height, 12. The lateral area of the cone inside is 1/2 2 pi times the radius, which is 5, times the slant height, which is 13. So that's going to give me 120 pi for the lateral area of the cylinder, plus 65 pi for the lateral area of the cone. That gives me 185 pi units as that lateral surface area. So now we have to find then the area of the base. The area of the base, just this one, is going to be pi times the radius squared, or 25 pi. My total surface area for this solid is 185 pi plus 25 pi. So 185 plus 25 is 210 pi units squared is the surface area of that solid. One more problem to look at, and that is the paint roller. You have two paint rollers. One has a length of 11 inches and a diameter of 2 inches. So if this is my paint roller, that's paint roller A. Its length is 11 inches and its diameter is 2 inches. And then I have B. Roller B has a length of 7 inches and a diameter of 3 inches. So the diameter inches, but its length is less. That's 7 inches. There's my paint roller. And I want to know which roller would spread more paint on the wall in one revolution. One revolution would be if it went around once. So that's actually just the lateral area of the roller. So the lateral area of paint roller A, the radius is equal to 1, is 2 pi r h. So 2 pi times the radius 1 times the height 11, which is 22 pi for paint roller A. The lateral area for paint roller B, again, 2 pi RH. I have 2 times pi, but now my radius is 1.5 and my height is 7. So I have 2 times 1.5 times 7, which gives me 21 pi. So roller A covers more area. The quiz should be very similar to the review sheet, so go over the problems that you're uncertain of several times, and then you'll be better prepared for the quiz. I'll see you tomorrow.